Welcome to the Mind Spark, bringing you the latest news from around the world. I'm sure you've heard the news. Cosmic shockwave James Webb detects mysterious signal from universe's edge. The James Webb Space Telescope, our most powerful eye in space, has peered deeper into the past than ever before. It's like a time machine, capturing the faintest, oldest light in the cosmos. But what it found has shaken the foundations of astrophysics. Webb detected a signal, an ancient pattern of light that challenges our story of cosmic origins. This isn't a message from aliens, but something even more profound, a snapshot of a universe that matured far faster than we thought possible. The light Webb captured began its journey over 13 billion years ago, when the universe was just a few 100 million years old. This signal is a spectrograph, a rainbow of light revealing chemical fingerprints of elements, stars, and galaxies that are far more mature than our theories predicted. It's a cosmic shockwave, forcing us to rethink everything. The universe didn't slowly build its first structures. It seems to have burst into complexity with astonishing speed. Every astronomer is now looking at their equations with a new sense of wonder and a little dread. The universe is far more creative and surprising than we ever imagined. The story of the cosmos has a new, unexpected first chapter, and we are the first generation to read it. The dawn of time is whispering, and we're finally listening. What did the James Webb Space Telescope actually see? Infrared light, ancient, stretched by the universe's expansion from the edge of the observable cosmos. The signal came from a galaxy or a cluster of young galaxies just 300 million years after the Big Bang. The surprise isn't just the distance, it's the complexity. Our models predicted the first galaxies would be small, chaotic blobs of gas and primitive stars. Instead, Webb found heavier elements, oxygen, carbon, already present. That means multiple generations of stars had already lived and died, far faster than we thought possible. It's like finding a multi-layered cake minutes after mixing the first ingredients. This single detection forces us to ask, was the universe seeded for complexity from the start? Did stars form and die at breakneck speed? Or is there an unknown process at play? The data is clear. Our understanding is what's being stretched. The universe we thought we knew is beginning to look like a stranger. Webb's discovery is a cosmic impossibility, staring us in the face. Scientists everywhere are scrambling for answers. The cosmos just got a lot more mysterious. This discovery doesn't just add a page, it rewrites the first chapter of our cosmic story. For decades, we thought the universe built itself slowly, gravity pulling gas together over eons to form the first stars and galaxies. But Webb shows us a different narrative: rapid, explosive creation. Massive, organized galaxies existed far earlier than we thought. Our models of gravity, star formation, and cosmic structure are missing something crucial. If galaxies formed this quickly, the conditions of the early universe were far more dramatic. Maybe the seeds of structure were larger, or dark matter behaves in ways we don't understand. We're being forced to reconsider the pillars of cosmology. This isn't a crisis, it's how science advances. The James Webb Telescope is guiding us to a new understanding. The universe's childhood was far more dramatic than we ever imagined. To grasp this, we must journey back before stars, before galaxies, into the cosmic dark ages. After the Big Bang, the universe cooled and became transparent, but remained dark for hundreds of millions of years. No stars, no galaxies, just a vast, silent sea of hydrogen and helium. Then gravity pulled the densest gas together, igniting the first stars, monsters hundreds of times more massive than our sun. These first stars pierced the darkness, marking the era of reionization. Their intense radiation cleared the cosmic fog, making the universe transparent to light. Imagine a dark room filled with fog, then powerful searchlights cut through, clearing bubbles that grow and merge. This is how the universe woke up. Webb's findings show this process happened much earlier and faster than we thought. The first stars and galaxies must have formed sooner and in greater numbers. The cosmic dark ages may have been shorter, a sudden brilliant sunrise instead of a slow awakening. The universe was in a hurry to leave the darkness behind. The dawn was more explosive than gentle. Our models must catch up to this new reality. Among Webb's most stunning discoveries are the so-called impossible galaxies. These are massive, well-formed galaxies that shouldn't exist so early in cosmic history. One, nicknamed Schrödinger's galaxy, appears as a mature spiral when the universe was less than 1 billion years old. It's like finding a fully grown oak tree that's only a week old. This suggests galaxies can form much faster than the slow, violent mergers we've always modeled. These impossible galaxies aren't just oddities. They're evidence of a major flaw in our thinking. Webb is finding them consistently, not just as rare exceptions. Maybe galaxies can form directly from massive gas clouds, bypassing the messy merger process. The existence of these ancient structures forces us to reevaluate the cosmic timeline. Star formation, heavy elements, galaxy assembly, it all happened faster. The universe's rulebook is being rewritten. Beyond galaxies, Webb is shining new light on the universe's expansion, a puzzle known as the Hubble tension. For a century we've known the universe is expanding, but how fast? Two best methods give two different answers for the Hubble constant. One measures nearby galaxies using standard candles, the other predicts expansion from the early universe's afterglow. Webb's precision was supposed to resolve the tension, but instead, it confirmed the discrepancy. The universe appears to be expanding faster today than our models predict. This isn't a measurement error, the tension is real. Something fundamental is missing from our model. The Hubble tension is now a cosmic crisis. Webb's data is forcing us to confront the limits of our understanding. The universe's expansion is more mysterious than ever. We're on the edge of a new revolution in cosmology. The Hubble tension and impossible galaxies are making us question the cosmological principle. The idea that the universe is the same everywhere. What if it's not? Maybe our local patch is different, a vast cosmic bubble or void. This could make the expansion in our region appear faster than the global average. It's a radical idea, but Webb's deep surveys can test it. By mapping galaxies across space and time, Webb checks if the universe is truly uniform. If not, our models must change. The laws of cosmology might be local, not universal. It would be a profound shift. Maybe we don't live in a typical part of the cosmos. Our cosmic view could be biased by our unique location. The universe may be far more complex and varied than we ever thought. At the heart of the expansion puzzle is dark energy, a mysterious force driving the universe apart. It's not dark matter, but a repulsive energy making up about 70% of the cosmos. In our models, dark energy is a constant, but what if it's not? Some scientists propose it's dynamic, changing over time, a concept called quintessence. If dark energy is growing stronger, it could explain the accelerating expansion. Or maybe it's patchy, varying across the universe. Webb and future telescopes may reveal its true nature. We're moving from acknowledging dark energy to probing its essence. The answers will determine the universe's fate, endless expansion or something stranger. The dark push is real and we're just beginning to understand its power. When our best models fail, it's time to get creative. The puzzles from Webb, impossible galaxies, Hubble tension, have opened the door to radical ideas. One, maybe our universe is the inside of a black hole in a larger cosmos. The equations for the Big Bang and black holes are eerily similar, or perhaps time itself flowed differently in the early universe, allowing galaxies to form faster. These aren't mainstream, but they show science grappling with profound mysteries. Our understanding is just one model. When data doesn't fit, we must consider the unimaginable. The universe is almost certainly stranger than we can conceive. We might be living in a cosmic mirage. New eyes and new ideas are needed to see what's truly real. The James Webb discoveries are not an end, but a beginning. We stand at a new threshold in our cosmic journey. Every image and data point is a piece of a grand puzzle. The impossible galaxies, Hubble tension, and dark energy questions are the shores of a new continent. Future missions will map the universe in greater detail, testing our boldest ideas. We are building better eyes to make sense of the strange new cosmos Webb is revealing. Our story is far from over. The quest to understand the universe unites us all. These discoveries remind us we are explorers on an ocean of mystery. Our place in the universe is defined by the questions we dare to ask. Webb has given us new, deeper questions. The whispers from the dawn of time are growing louder. Our voyage into the great unknown has only just begun.